We're on problem 63. 63. Carlotta can drive from her home to her office by one of two possible routes. If she must also return by one of these routes, what is the distance of the shorter route? So essentially, she has a long route to go to her office. That's her home. That's her office. And then she has a short route with fewer curves. That's my guess. And she could go and come back by one of the two of that kind of looks. Well, anyway. Statement number one. Statement number one. When she drives from her home to her office by the shorter route and returns by the longer route, she drives a total of 42 kilometers. So when she goes this way, shorter route, this way, and then longer route back, it's 42 kilometers. So shorter plus longer is equal to 42. And that by itself doesn't let me know what the distance of the shorter route is. Statement number two. When she drives both ways from her home to her office and back by the longer route, she drives a total of 46 kilometers. So she goes by the longer route and then by the longer route again. So 2 times the longer route is equal to 46 kilometers. Well, this by itself helps me figure out what the longer route is, but we want to know the distance of the shorter route. So this, I can just eyeball this. The longer route is 23 kilometers. But if you want to know the distance of the shorter route, you would need this information as well. And whatever. The shorter route plus 23 is equal to 42. So it's what? The shorter route is 19 kilometers. So you need both of the statements. Both statements are sufficient, but one by themselves are not enough to figure out what the shorter route is. If they asked for the longer route, just statement 2 could have been good enough. Next question, 64. Is x greater than y? X greater than y. My computer is updating something. It's a little bit. Is x greater than y? Statement number 1 tells us that x is equal to y plus 2. Well, let me think about that. No matter what y is, x is going to be 2 more. Even if y is a negative a million, x is still going to be a bigger number. It's going to be 2 more than negative a million. If it's y is negative 10, this will be negative 8. No matter what, x will be greater than y. So this is statement 1 is sufficient. Statement number 2. Statement number 2. X over 2 is equal to y minus 1. This doesn't look as clear there. So x is equal to 2y minus 2. So we just have to come up with a condition, one y where y is less than x, and another y where y is greater than x, and then we would have proven our point. So let's think about it. When y is 0, this is using statement number 2. When y is 0, what's x? X is minus 2. So that's a statement where y is greater than x. And then when y is, when y is equal to 10, what's x? 20, x is 18. So this is a statement where y is less than x. So statement number 2 actually tells us nothing about whether x is greater than y or y is greater than x. So statement number 2 is useless. Statement number 1 alone is sufficient. Next problem. 65. If m is an integer, is m odd? M odd. Statement number 1. Statement number 1. M divided by 2, not, they write it real big and bold, not even integer. Not even integer. Well, that doesn't tell me much. That doesn't tell me that this is odd. In fact, it's not an even integer, but if this was an odd integer, then that means that m is an even integer, right? Anything that's divisible by 2 and results in an integer, right? That's essentially saying that it's divisible by 2, by definition is going to be even. So for example, what if m divided by 2 is equal to 3, right? 3 is not an even integer, but still m would equal 6. And then m would be even. And they're not telling us much here. M divided by 2 could be equal to 2.5, in which case m would be equal to 5. So then it would be an odd integer. So this by itself doesn't give me much information. Statement number 2. M minus 3 is an even integer. M minus 3 is even. Well, this is useful, right? If you subtract an odd number from a number and you get an even number, this number is going to be even. And let's think about that. If I have an even number, let me just write a bunch of numbers. Let's see, x. Let me write x, y, and z. And let's say they're consecutive, right? Actually, let me write it even better. Let's say that x is even. Let's say x is even. Let's say x is odd. Then x plus 1 is going to be what? It's going to be even, right? The next number will be even. Then x plus 2 is going to be odd. And then x plus 3 is going to be even. And then if you go the other way, actually I should have gone the other way first. X minus 1 would be even. X minus 2 would be odd. And x minus 3 would be even, right? When you subtract, if you have an odd number and you subtract out, and if you subtract out an odd number and you get an even number, then this number is going to be odd. So this statement 2 by itself is actually sufficient. And play around with some numbers if that intuition doesn't make sense. Statement 2 by itself is sufficient to solve this problem, and you don't need statement 1 at all. Next problem. 66. What is the area of the triangular region ABC above? Well, they've drawn us a little triangle. So I will draw us a triangle. Let's see, we have our base. And then it looks pretty symmetric. I'll try to draw it the way they drew it. It's one end. That's the other end. And then this is the altitude. Good enough. And then they label it A, B, C, D. This is a right angle. This is x degrees. All right. What is the area of the triangular region? So area of a triangle is base times height times 1/2. So if we can do that, then we're all done. 1. The product of BD and AC is 20. So BD times AC. Oh no, sorry. BD times AC. Oh, that's it. So BD is the height. So area, let me just write it. Area is equal to 1/2 times this altitude, BD, times the base, times AC. Right? Statement number 1, they tell us what BD times AC is. They tell us that BD times AC is equal to 20. So that immediately follows, if this thing is equal to 20, then the area is equal to 10. You didn't even have to figure that out. So statement number 1 by itself is sufficient. Statement number 2. X is equal to 45 degrees. This one's a little bit more interesting. X is equal to 45 degrees. Well, I mean, we could, do a little angle game. We could say, okay, this is a 90-degree angle, and we could say that if this is 90, this is 45, then this is going to be 45. Actually, that's about where we could stop. And this tells us no information about what any of the sides are. So you could imagine if this is 45 degrees, but this could be a 1,000,000-mile high triangle, or it could be a nanometer high triangle. We don't know. It could be of any size. You could scale it up or down. This just tells us the degree and the angle information. So 2 by itself is useless. So for this one, statement 1 alone is sufficient to answer this problem. A. Next problem. 67. What is the value of B plus C? B plus C. All right. Number 1, they tell us that AB plus CD plus AC plus BD is equal to 6. And this by itself doesn't help us much because we have all these a's and d's here, and they could be anything. So we can't solve for b plus c. But I'm already suspecting that if we could factor out the a's and the d's somewhere, so we can factor out the b plus c's, then we might be able to figure out the numbers if we're given more information about a and d. Statement 2, and they give us more information about a and d. A plus d is equal to 4. So let me see if I can simplify this top one. Let me see if I can factor out a bunch of b plus c's. So if we think about it, let me think. So if you take this term and that term and you factor out the a, you get a. Let me do it in a different color. So this term and that term is equal to a times what? B plus c. B plus c. Right? You can multiply that out and you get ab plus ac. And then plus, and let's do the same thing with this term, d. That's d times c plus b, but we can switch the order, b plus c. And if you don't believe me that this equals this, multiply it out. All I did is I grouped the ab in the ac terms and then factored out the a, and then I grouped the cd and the bd terms and factored out the d. And then now we can factor out a b plus c. We can do the reverse distributive property again. So now this equals a plus d times b plus c. Right? And if you don't believe me, just multiply b plus c times a, and then b plus c times d, and you get that. Right? That's just a distributive property. But now we're ready to solve. Because they told us that this thing is equal to 6, so this thing is equal to 6. And they tell us that this thing is equal to 4. This is equal to 4. So b plus c is going to be equal to 6 over 4, or 1.5. And we're done. You need both statements together. Both statements together are sufficient to solve this problem.